So hello everyone. As I have already promised myself that I'll be stuck to the DSA practice that I have left before, and revising this concept from GFG 160 problems, I have found the second problem as far moving all the zeros at the last of the array. So while thinking about this one, so I just clicked with first of the concept of two pointers, like placing the first pointer on the place where there is a non-zero element, and moving the other pointer to the zeros in that array. And by swapping both the position, we can just move the zeros at the very end. But implementing it would make it a complexity of something like better solution. So I go for the most brute force solution, which was having another array of size order of n, which was initialized with the value 0, and putting the non-zero values from the given array to that temporary array. And after all the shifting were done, so the remaining places are uh, already covered with 0, as we have initialized this temporary array with the 0 values. So we can return this temporary array as the shifted zeros at the end. Okay, so when I thought about the brute force approach, so it was like this, but I didn't initialize the array from the 0 index, because it would be making, yeah, I reminded the concept as when I was initializing the array with 0 values, so I have to just give the size of the array, of which size I am going to initialize that 0 element array. And if I'm giving the size, so the values are getting pushed after that zeros. So that was the main problem in initializing the size. And so I basically made an array, and I didn't initialize its size. And after that I went to and after that I went for pushing all the elements of the array, given array, to that temporary array, which are not zeros. And after pushing all these values, I just shifted towards the zero values, which was size of the given array minus my temporary sized array. Size of the given array minus my temporary sized array, which was the difference with the zero values. So I just subtracted both the sizes, both the value of the sizes. And I have, let's say I have the value n, and I continued a while loop and times to push only the zeros at the end. So by this I have took n time complexity of order of n, and space complexity also of order of n. So I have to optimize this order of n space complexity to something like order of 1 or something better. But I cannot optimize the order of n time complexity, because it is like I have to traverse the whole array. I cannot move the zeros at the last without traversing the array. So, okay, so the second approach is like creating uh, creating two pointers. One would be taking zeros as their element, and the other would be taking non-zero elements. Like if the value is non-zero, so it would be pushing it to the other pointer element. I'm going to explain the whole concept. Like I'm taking an element index at zero value and the other index also at zero value. I started checking each element, let's say I, each element, is it zero or not? Is it zero or not? If it is not zero, then push the jth element at the ith position. Put, push the jth element at the ith position. So it would be same for the conditions till I not found zeros in my array. But after, whenever I found zeros in my array, I would encounter and think that I have to increment one pointer, but the other pointer get stuck at the same place. Like if I am incrementing I and j at the same time after pushing j value at the ith place, which is same, but whenever I encounter 0 at the ith place, so I will not push I forward, but I will take j forward, and I will push the value of j at this place, and then I will push the value of j at the previous place of I, then I will push the value of j at the previous place of I. In this way, whenever I reach the end of the array from I value, I will just stop the traversing. At the end of the array, I have to push three zeros, as I have already told you that we have to push three zeros. As I have already told you, we have to push three zeros at the end of the array. So I'll push three zeros, n number of zeros which are given in that array, and I'll push that zeros in the end of the array, and I will get the all the zeros shifted towards the right. If you people are not getting the idea, so I'll just make a dry run of this by making you understand. So let's say I'm taking this test case. The test case is like the test case is like 1 2 0 4 3 0 5 0. This is the one array. This is the one array. I have taken ith element at the zeroth index and jth element at the same index. For shifting the For traversing this array, I will take ith element at the zeroth position, and jth element is also at zeroth position. And the order is like, you can write the array is like 1 2 0 4 3 0 5 0. So I will, at the zeroth element index, I have a j as a non-zero element, so I will increment the both j and I as well. At the 1th element position, I have 2, which is a non-zero element, so I'll increment both the pointers. So j will be incremented and I will be incremented. At this position, at position 2, I encountered the first zero of my array, so here I only increment j, but I will not move I from here. I will not move I from here, and I will push the value of j from this place to the ith position of the same array. So it will be like 1 2 4 and 4. Again, now I will be incremented because the value has been pushed at that position. For the next position, I will increment the j because I have pushed the jth value at that place. So the j is at fourth position, I think, fourth position, but the I is at the third one. At this time, I have I as the non-zero element, so I will directly push the value of j at the ith position. So, and increment the I and j at the same time. So the array is like 1 2 4 and 3, because I have pushed the 3 at the third position. Um, Now I have incremented I and j, so I is at my fourth index and j is at my fifth index. I will push the value of, now I encountered j as a zero value element. Now I encountered j as a zero value element, so I will just push the j at the ith position and I will increment only j. So I have pushed the j. I will skip this iteration and I will go for the next iteration. I will skip this iteration and I will go for the next iteration. I have incremented the j. Now I have encountered 5 as the jth value. So I will push this value at the ith value position. So it is like 1 2 4 3 5. Now I will go for j I incrementing, and I is at 0. I will skip. J has also skipped to last 0. J has reached the end. I is at 5 index, fifth index, and whenever I encounter 0, I will just increment the j. Whenever I increment the j, I am going out of the array size, so I will break the loop. So at the end I encountered 1 2 4 3 5. This was the array, but at last I will push all the zeros, like from the size of the zeros to the this new size of the zeros. I will subtract and found how many zeros I have skipped, and after that I will push all the zeros at the last of the array. By this method we can find the move all the elements to the last of the array. Okay, so it was a very nice explanation. I think that's all from my side. Okay, thank you.